Welcome to today's topic or lesson. In today's topic, we are going to learn about physical quantities. Yes, this is a new subject, physics. Physical quantities such as fundamental and derived quantities. Fundamental and derived quantities. First, we'll start by defining what is a physical quantity. Physical quantities, these are measurable properties, either directly or indirectly measurable properties of a material that has numerical value. These are the measurable properties, either directly or indirectly, possessed by a material that has a numerical value. For example, the temperature of that material, the weight, the mass, etc. Let us continue. Now, there are two types of physical quantities. They are the fundamental quantities and the derived quantities. The fundamental quantities, often called the basic quantities, and the derived quantities. Now, we are to look at their differences and how to properly know them. Okay? Fundamental quantities. These are quantities that do not depend on any other physical quantities. These are quantities that do not depend on any other physical quantity. Or you can define it as, these are quantities that are independent of other physical quantities. Or you might say, this is the very basics of the physical quantity. That is, it cannot be reduced any further. It is the most basic of basic. It is as basic as there are cells in the human body. Okay, let us look at their examples. I have a mnemonics for it. I use the mnemonics T Mattel for the examples of fundamental quantities. T stands for time, which has its unit in seconds. M stands for mass, which has its unit in kilogram, gram, milligram, as far as it is gram. A stands for amount of substance, or also called mole. Mole is the amount of substance or the amount of matter a body contains. T is while the other T stands for temperature in degrees Celsius, in Kelvin, in Fahrenheit. E stands for electric current in ampere. L stands for length, that is meters, centimeters, kilometer, wherever. Then L stands for luminous intensity. Luminous intensity measured in CD or called candela. Okay, now we will go into the derived quantities and its examples. Derived quantities. These are quantities or physical quantities gotten or derived from the fundamental quantities. These are physical quantities gotten or derived from the fundamental quantities. They depend on the fundamental quantities because they are gotten by multiplication or addition of fundamental quantities. These are their examples. The following are the examples of derived quantities. Weight. Weight is the force or pull or attraction of a body by the Earth's gravitational pull towards its center. Weight is a derived quantity. It is gotten from the product of mass and acceleration. Basically, mass times acceleration is weight, and its unit is in Newton, commonly known for gotten from or mimicked or derived from the product of mass times acceleration. Now, do you know the full name of the scientist famous for depicting the apple that fell on his head, knowing the weight of an object? The next one is force. Force is a derived quantity gotten from the product of the mass of a body times its acceleration. The mass of a body and how fast the velocity of that body is changing, the product of both of them would give you the force. For instance, I punch you with my 2 kg hand at a speed of 9 meters per second square, then my force would be 2 times 9 equals to 18 Newton. Force is also in Newton, or you'd write kilogram meters per second square. Then the next derived quantity is momentum. Momentum is gotten from the product of the mass of a body multiplied by the velocity of that body. It is gotten from the product of the mass of a body multiplied by how fast the displacement of that body is changing with time. Its unit is kilogram meters per second. Then the next derived quantity is power. Power, everybody shout power. Power is a derived quantity gotten from the product of a force on a body and the displacement that force gives the body in a certain direction. So power is force times displacement. Then the next one is volt. The unit of power is Newton meter. Then the next one is volt. Note, there are different types of power. There is electric power and then there is the power for Newton meter. Electric power is measured in watts. It is gotten, I will tell you the value as a fun fact. Volt. Volt is gotten from the product of the current multiplied by its resistance, and this is known as Ohm's law. Volt is gotten when current is multiplied by resistance. Area is also a derived quantity. It is gotten by the product of the length of a body multiplied by its breadth. Length times breadth equals to area, or L square. Volume is gotten from the product of area times height, or the product of length times breadth times height, or its unit is in L cube. Then speed is also a derived quantity. It is gotten when the distance moved by an object is divided by the time taken to move that to cover that distance. Its unit is in meters per second. Meters per second. Linear acceleration. Linear acceleration is gotten from the change in velocity divided by the time it takes to change. Change in velocity divided by time is linear acceleration, and its unit is in meters per second square. Density. Density is just how much mass an object has in less of a volume. Basically, it is gotten from mass divided by volume. The mass of an object divided by its volume. The mass of an object divided by its volume is its density. Okay? Now, fun fact, let's say we have two objects, A and B. If object A is denser than object B, then we can say that object A has more mass per volume than object B. The next derived quantity is pressure. And the value for density, the unit of density is in kilogram per meter cube. Kilogram per meter cube. Then the next one is pressure. 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 Pressure is gotten when force is divided by an area. Force over an area. Basically, pressure is the force acting on an area. Acting on an area or a unit area. Its unit is in Newton per meter cube. The next derived quantity is impulse. Impulse is gotten from the product of force times time. The force on a body and the time in which the force acts is known as the impulse. The next derived quantity is velocity. Velocity. its unit is in meters per second. It has the same unit as speed. Do not worry, most of them have the same unit, like acceleration, like weight and force has the same unit, like velocity and speed have the same unit. Do not worry, there is a special part or different. I will differentiate them into why and how they are the way they are. We are moving on to the next topic of derived quantities. We are to look at types of derived quantities: scalar and vector quantities. Velocity is gotten when the displacement or the distance displaced by an object is divided by the time taken to displace such a distance. So we move on to scalar and vector quantities. Scalar and vector quantities. Note, there are even more derived quantities. However, if I were to list them, obviously we won't wait that long to see all of them. So apart from now, I am giving you a do-it-yourself assignment. Now, the do-it-yourself assignment says list 3 other examples of derived quantities apart from the ones listed above. List 3 other examples of derived quantities apart from the ones listed above. Let me see if you can do it. Send your answer to the comment below. Now, there are 2 types of derived quantities. Examples are the scalar quantities and the vector quantities. The scalar quantities and the vector quantities. Now, let us define and see why they are different and how they are different from each other. Now, scalar quantities. Scalar quantities are quantities or derived quantities with only magnitude and no direction. These are quantities with only magnitude and no direction. When I say magnitude, I mean that it has only numerical values and no direction at all. Then vector quantities. These are quantities described in both magnitude and a specific direction, Examples of scalar and vector quantities are mass, time, speed, distance, temperature, energy, volume, pressure, density, and area. Examples of scalar quantities are mass, time, speed, distance, temperature, energy, volume, pressure, density, and area. Note that these quantities do not have a direction. They only have a numerical value or a magnitude. They cannot be described in any specific direction. Now, the examples of vector quantities are force, velocity, displacement, acceleration, momentum, electric field, thrust, torque, weight, and impulse. There are other examples of scalar and vector quantities. However, I would leave you with 10 of each of them. Now, let us move on to comparison of why and how most quantities have the same value and what does it fully mean if they do not have the same physical quantity. Like one has meters per second, as in speed and velocity having the same value, while one is a scalar and the other is a vector quantity. Okay. Now we can see an example: weight versus force. They both have the same unit, which is Newton. Weight is the gravitational pull on a body by another bigger body towards its center. Force is the product of mass and the acceleration of a body. While weight is the gravitational pull on a body by another body towards its center. Although they have the same the same units, they are very, very much different. Weight is a weight is a vector quantity, and force is also a vector quantity. So they are both vector quantities. However, they both have different description, even though they have the same units. Now, speed versus velocity. Speed is a measure of how fast a moving object covers a distance within a specific time in no direction. It is a scalar quantity. It has no direction. An example is 10 km per hour. 10 km per hour, or 10,000 meters per 3,600 seconds. Now, velocity. This is a measure of the displacement of an object within a period of time in a specific direction. An example is 10 km per hour towards the east. 10 km per hour towards the east. Fun facts time. In a vacuum, a heavy object and a light object have the same acceleration. This means that if I were to throw a boulder weighing 2 tons or 2,000 kilograms from a height, however, in a vacuum, and I were to throw a light feather, they would both reach the ground at exactly the same time. This was first proven by Galileo Galilei, mathematically and physically. Thank you for watching this channel. If you know you've learned something today, please like, subscribe, comment, and share. Remember to do it yourself. Remember the assignment. If you cannot do it, please ask me in the comments and I shall answer perfectly well. Do not worry, things will get better and this channel will get better. Thank you and have a blessed day. Thank you.